So this topic is called improper integrals. Right? And as you can see above me, when we're talking about an improper integral, we are looking at integrals which have one of two things happening. Either A, one of the limits of integration is positive infinity or negative infinity, or B, somewhere inside the actual limits that we're dealing with, the function itself becomes infinite. Right? And if we put that into mathematical expressions, you're looking at something like these right here. All right, we see the integral from 1 to infinity of 5 over x dx. All right, so we're beginning our region when x is equal to 1, but there is no upper bound. Right? Can we actually find a limit? Can we find a value for this? That's what is coming up. All right. In this situation right here, this is the integral from 0 to 4 of 1 over x squared dx. Okay, so initially we think, well, wait a minute, that's 0 and 4. But think about it for a second. What's the graph of 1 over x squared look like? Right? If we do a quick graph, we know that 1 over x squared does this. All right, so in fact, the function is not defined when x is equal to 0. But that's when we're supposed to begin our as our lower limit of integration there. Okay, so can we actually get the area under the curve from 0 to 4? That's an improper integral. You might also have a situation like this, where you have dx or 1 over x cubed or dx over x cubed. In that situation right there, well, we're starting at -1. That's fine. We can plug it. We can work with -1. We can also work with 1. But we know that we have an issue right there in the middle of our region when x is equal to 0. All right, the function is becoming infinite somewhere in between our limits of integration. All right, so these three examples are all improper integrals. All right, now as far as improper integrals are concerned, some of them can actually be solved. Right? And that's what we're going to talk about in future videos. Some of these integrals are actually divergent. All right, they cannot be solved, and I'll give an example of that as well. All right, but if you can't actually come up with an answer because the region, because it's an unbounded region, it just keeps growing and growing and growing, there's no way to find an area of that region. Okay, but sometimes, even though the region is unbounded, its rate of growth is so small that we can actually come up with a value for that integral. Right? And so what we're looking at in these future videos is how mathematically to arrive at those values.